I still taste sweet. Some people call me a bad apple, but I may be the sweetest apple on the tree. I've got the notion to tell you about
As you help me do up my laces before. I feel like I'm way too.
I don't know if I want to open my book. It's going to get all wet.
I know. Might as well wait.
Yeah.
Okay.
Here we are. Hi, stranger.
Hello.
I missed you.
What have you
It's been
up to?
so long.
It has been very long. Yeah. Well,
Here we are.
here we are. We made it. We made it. So welcome back to those who are joining us. This is season 2
Season 2, baby.
of Between Two Rows. Pretty crazy.
Yeah.
What's our opening again? So between two, it's been a while.
It's been
We're
a while.
bit rusty. I feel like
we're still waking up.
I feel like every time we do this, it's like, okay, did we do this? Yeah, so we have come out of dormancy a bit sooner than the trees.
Yep.
Just because we felt that why not?
It was time.
Why not film in the rain?
It was time. Yeah.
Because we love you guys. And we love doing this.
What would be a better day than when it's raining?
Yes. Perfect.
And cold.
And cold. Yeah. I guess we're well equipped, so that's nice.
Mm-hmm.
But yeah, as we said, season 2, Between Two Rows, where we take grower questions or industry questions between two rows.
Yeah.
So now we are currently in the Simcoe cider cultivar block. It's an experimental block run by John Klein.
Mm-hmm.
And as you could tell, there's a few things on the ground.
'Tis the season. What does an orchard look like this time of year?
Yes.
Pruning has been happening.
Yeah, and who knows? We'll see how fast we can film, but they were pruning behind us. Maybe you'll see some activity.
Yeah.
But yeah.
Yeah. Love it.
Okay.
So same sort of format, right? We're going to answer grower questions, things that have kind of come in and or things that are kind of interest or timely. And so as always, submit questions, give us some feedback, whatever it is that you want to talk about or want us to cover. And we try and kind of match it with the season, the topics that are kind of, on top of mind at the present time. And yeah.
Mm-hmm. Oh, I'm Erica DeBrouwer.
Oh.
And this is
season 2. We're going to get this. I'm Christy Crick McGuffin.
Yeah.
We are your hosts.
But as always, we start off with a cider.
A cider, yep. And so today we're featuring one of our winning cideries for the Ontario Craft Cider competition that was held in February. And so this is Spy Cider House and Distillery. They're based in the Blue Mountains area. Mm-hmm. Have a great cidery if anyone's up there and wants to stop by and try all of their different ciders that they have. The one that we're having today specifically is the Spy Estate. And this is made from their heritage apples. So those of you who are kind of looking for like a classic, more traditional style cider, then the heritage apple varieties are the ones to go for. I can't see the bottom of the mug, so I don't know. I don't know where we're at.
Keep going. Can you hear that fizz? All right. Well,
cheers to.
I can't. I
can't
use my right arm.
We're working with an injury.
For those of you who know the injury. You know the injury?
So it's left arm only for the next little bit. All right, well, cheers. Cheers to season 2.
Mm-hmm. Oh yeah.
So a lot of times with heritage varieties, then I find that they tend to be much more like kind of drier, classic kind of taste of a cider. So if you're not one who prefers the sweet ciders, then leaning more towards the heritage, I think is kind of a nice route to go.
Yeah.
To see that mix.
Christy and I are, we always enjoy a drier cider.
Yeah.
So heritage fits well
Yeah.
into that.
Yeah, completely.
And it has a very, they refer to it as funky.
Funky.
It's like a funky cider, but there's a wide variation of how heritage ciders can taste. So if you haven't had the opportunity, please try them.
Yeah, for sure. Awesome. Okay, so we're going to get into topics. You're pulling out your little cheat sheet?
My notes, as always, because I cannot. Christy is amazing.
No.
And she'll have like a few bullets. I'm like, okay, let me read this entire paragraph for you. So yeah,
it's about just saying it with confidence.
Yeah.
And you got nothing to lose.
I can work on that. Yeah. We'll see. We'll get there eventually. Okay. So
what do you got?
Yes. Although we don't see it in this block.
Well, the row next to us.
The row next to us.
Oh, we should have picked a better row there.
There's one leaf right here.
Okay, that's something.
Basically, my question is, why are my apple trees still holding brown leaves?
Mm-hmm.
Why are they holding brown leaves? It is a very good question, and I'll tell you up front, not a great answer.
Well, it's a good answer. It's just there may not be the details.
As with every question, you answer with more questions.
Yes, of course.
So, of course, that's where we'll land. But so I was like, oh, this is so interesting. We know that ambrosia apples
they're terrible for that.
Yeah, they often hold on to their leaves a lot longer, and I will get into that a little bit. But I was scrolling through social media, as one does, and I was like, oh, this is so interesting. Someone mentioned the term marcescence.
Okay.
And I was like, what?
Yeah.
Is that? So marcescence is a botanical term, and it refers to trees keeping their dead leaves throughout the winter instead of dropping them in the fall.
Okay. So that it applies to across all species.
So that's what
it contains a variety of species.
So that's what I thought.
Yeah.
I was like, oh, okay, maybe there is a reason.
Yeah.
I'll delve into that a bit more. So it sounds like a reasonable explanation at first glance. But as I got into it, I was like, okay, this is not actually why, but I still thought it was cool. So we're going to talk about it. And then I'll get into ambrosia in a sec. But yeah, so it's marcescence. I'm going to actually read the definition. It's a species level genetically programmed leaf habit. So some of the trees like oaks and beeches, they naturally retain their dead leaves throughout winter because the abscission zone never fully develops. So then it's like, what is an abscission zone?
Right.
So it's a specialized layer of cells at the base of leaves, flowers, or fruit, and it's regulated by hormones or environmental causes. So it's actually that point where the leaf will drop from, or the fruit will drop from.
Okay.
So marcescence is genetically related. And I'll get into a little bit of a comparison about why apples are in fact not marcescent.
Okay.
Okay, so it's going back to oaks and beeches and those trees that really do hold on to their leaves. Scientists don't actually know why this is happening. They know that it is happening,
right?
That they are holding on to it, but they don't know the cause. Excuse me, not the cause, but the reasons why. So they might be protecting their buds from cold or herbivores.
Okay.
Apparently.
Okay.
It could be the timing of nutrient release, but it's built on the tree's DNA. As I said. So very, very interesting.
Yeah.
And there's still theories around
it. Or could vary depending on the species.
I assume so.
Yeah.
Yep. So the leaves don't die normally and the abscission zone is incomplete. And that's why they hold on to it, and they hold on to those leaves until spring, or there's like a mechanical or environmental force that drops them.
Right.
So yeah. So that kind of raises the question of like, why doesn't marcescence fit into apples? So there's 3 questions that I have, and it's, is the abscission zone anatomically incomplete? Is retention consistent across individuals and years?
Okay.
And is it a species level trait? So
Okay.
if it reaches, if it is true for all of those questions, then it is marcescent.
Okay.
And that is why apples
Yeah.
are not.
Yeah. Okay. Okay.
Yes. Very, very cool. So, basically, why doesn't it apply? Kind of got into that. The apple leaf abscission zone, it forms, right? It's a fully functional abscission zone in autumn. Microscopy has confirmed that.
Right.
So all apples do form this separation layer. And leaves are, as we stated, hormonally regulated. It's regulated by photoperiod. So that's how the leaves know when to drop or form that abscission zone, photoperiod and temperature.
Okay.
And usually it's consistent year to year.
Right. Right.
Right.
Usually.
Usually. So not all of the apple cultivars retain their leaves, right?
Right.
We're seeing it usually in ambrosia. It
Yep.
is a later maturing, well, not later maturing, but yeah, later fruit bearing maturity cultivar, which could be a reason.
Mm-hmm.
I'll get into that. But
some of our older late maturing varieties drop their leaves every year, no problem.
yeah, so it's really,
So it's something specific to,
it could
Yeah.
be related to a few factors.
right.
But again, so it's not all cultivars. It's not consistent across orchards or years.
Yeah.
Potentially.
Right.
And then it's strongly influenced. It can be influenced by management or the environment
Okay.
in apples, at least. And the variability argues that it's not a genetic leaf habit. That being said, we're limited on science specific to ambrosia.
Right. Because it's a new variety.
Newer.
New cultivar. New in the
yes.
apple world.
Yes, new in terms of lifespan.
Yeah.
To cultivars.
Yeah. And because it was a surprise find too, right? Like
Yes.
it wasn't part of a breeding program.
Oh, really? Okay, I didn't know that. I'm trying to rack my head around.
Yeah, from what I understand, and people can 100% correct me, but that it was a surprise find in a BC orchard or on BC land, that they then from there it kind of progressed into like, oh, this is really nice, and let's find out more about it. But it wasn't part of a designated program.
I love that.
Initially. The
Nice.
surprise finds. Mother Nature makes the best ones.
It is a wonderful apple.
Yeah.
Gotta say.
Yeah.
So yeah, for apples, there hasn't been any studies classifying apples as marcescent.
Okay.
So that's one indicator as to why. But there's no cultivar related science reviews as ambrosia being marcescent. It could be genetically related to why it holds on to leaves, but it's not specific to marcescence.
Okay.
And again, it's not all cultivars.
Right.
And science has shown that, at least.
Mhm.
So, all apple cultivars will definitely form an abscission layer. It's just whether or not the leaves actually drop.
Right. That they may hold on to them for different reasons.
Right. So that's what we're going to get into.
Okay.
So why do apples hold on to their leaves? So there's a few different reasons. I'll go into some of them. So it could be nitrogen related. And for those of you that grow ambrosia is pretty good at taking up nitrogen.
Mm-hmm.
So that could be a reason.
Okay.
So high nitrogen delays senescence, right? Because as you, nitrogen pushes growth.
Right.
Rather than
Yes.
not.
Yeah.
And in order to drop leaves, you want to stop growth.
Right. Okay. So because it's very proficient at taking up the nitrogen, then it's not shutting down as quickly in the fall?
Potentially.
Okay.
Yep. Yep. Because delayed senescence does delay the abscission zone
Right.
starting
Okay. Because that
activation.
the abscission zone, like that starts in the fall when the tree starts to enter into dormancy, then it's formed at that point in time. It's not that like as the leaf develops, it automatically has
Correct.
this zone. Okay.
It's
so that's just through
after
hormonal changes and then it
hormonal
starts to
changes
separate.
based on photoperiod and temperature.
Right.
And as it's getting ready into dormancy,
Yeah.
then it starts
Then it
forming that
creates.
abscission zone.
Okay.
Yep, you're exactly right. So nitrogen, it could be due to continued irrigation or late vigor. So ambrosia, I don't think that it's commonly known as a very vigorous variety, but that could change based on potentially root stock
Right.
and the season.
Yeah.
So it's vigorous, I guess, in different senses, I would say, for ambrosia. Like
Okay.
it is a very vertically growing cultivar, and it can have a later push.
Mm-hmm. Yeah.
Because it is a later maturing apple. So that could be one of them. The continued irrigation, this was something that was stated, and I assume it's more if you're changing the environmental factors significantly to delay something further on.
Okay.
Not necessarily that it's bad to irrigate later. It's just more if you're like fertigating or you wouldn't want to push growth.
Right.
Pretty much.
Because all that stuff would just be continuing to accelerate the growth.
Exactly.
Yeah.
Okay. What else do I have here? Early frost, which is interesting.
Oh.
So frost can kill the leaves before the abscission layer actually forms. Very rare here.
I was going to say, I don't think I've ever seen a frost event that like outright kills a leaf. Like I've seen some frost burning.
Right.
But then the leaves just kind of push through.
Yeah. I don't think that it's very relatable in Ontario.
And so the leaves would die and then just hang on just because they don't have any sort of release point. They don't have
the layer to drop.
Interesting.
Yep. So they remain mechanically attached.
So then do you have to if you wanted to then remove those leaves, you would be like causing rips and tears.
Yes.
To remove them.
Yep. Potentially.
Yeah.
Like depending if that abscission, like how far along that abscission layer is formed or is not formed.
Right. Interesting.
Interesting enough, we have light crop load.
That increases the risk of them holding the leaves?
So basically, a low crop load will push more vegetative growth.
Okay, yeah, right. That they push all their energy then into that.
Because they want to put on fruit for the next season.
Yeah, makes sense.
So
okay.
It could be related to, again, vigor. All these things are related to each other and intertwined. But yeah, I found that pretty interesting from a crop load perspective. If you want to try to keep your trees as well balanced as possible.
Right.
It's not easy.
Yeah.
But that could be a potential issue. Again, I should have started with the fact that leaves holding onto their tree, at least in ambrosia's case, haven't been detrimental in a sense.
Right.
Like there hasn't been like, oh, you're holding onto your leaves, so this is going to impact things later on.
And that the tree still shuts down.
Right.
It still enters into dormancy, even though it's holding the leaves.
Yes.
But we don't necessarily know, like, long term, is that gonna, like, does it actually impact hardiness? Like, we just don't see it the next year?
Right. So it's kind of like, if you're thinking about these things that are compiling up, that are indicating there could be a potential issue, then maybe that's something to look into a bit more. So.
And having leaves on the tree is not going to impact the vegetative bud set.
No, because that has already happened.
Right. And so the new leaves will come out even if the old ones are still hanging on.
Yeah. I just want to see how many more potential causes I have. Oh, just one more. So, young or vigorous shoots. So young trees because you're pushing them
Right.
vegetatively again. So they can retain their leaves a bit longer,
Okay.
because that's where their sole focus is like vegetative growth.
Right.
And yeah, so those are the 5 things that I have. So it's your late nitrogen, your late vigor or irrigation, early frost before abscission,
Mhm.
which rare, light crop load, and then young or
Interesting.
vigorous shoots.
Yeah.
So those are the 5 that I have. Oh, I lied.
Surprise! A surprise 6th one.
Shockingly, I can't read my own notes. Well, as we stated, like, it's so environmentally driven
Right.
that we mentioned frost, but it's also any sort of additional stress. So actually, drought can initiate leaf abscission.
Can initiate it.
Initiate it.
Okay. Which
Because it's
which makes
stress.
sense. Yeah. That
It's
the trees
dropping.
start to drop their leaves. Yeah,
They're
and that's
trying-
what we saw that last year.
Yes.
Right. Yeah.
Because they're trying to hold on to as much resources as possible,
Right.
Rather than push new growth.
Right.
Temperature changes can interfere with abscission. So, as we said, we're having more variable weather.
Mhm.
So there could be a potential relation to that, whether it's like if you're having cold periods where you're going in and the leaf is developing its abscission zone and then it warms up suddenly,
Right.
could initiate drops sooner, or vice versa.
And the fact that we've got really warm falls now.
Mhm. So if we have really warm falls, it's not necessarily getting ready
Right.
to form that abscission layer.
Yeah,
It may
like
not
we have
enough
that
time.
photo period change, but we're not having that temperature change. And so is that enough to kind of trigger the hormonal
Yeah,
switch?
that's the question. So I did look into it, and it said a minimum of 12 hours to 24 or more hours is required for the completion of the reactions before separation can occur.
Oh, okay.
They didn't have a specific temperature
Mhm.
or length of time that's
But if
needed.
you get the fluctuations, then that's going to kind of interfere with that.
Exactly. And I lied. So there's
Oh my God, there's way more.
well, they all kind of relate, but it's rootstocks, which
Okay.
I kind of already
Yeah.
stated.
Yeah.
Like, and that's because of nutrient uptake.
Right.
It's that relationship that they have with the cultivar.
Yeah.
So,
That how much growth they're going to push.
yeah, right. So, like, if you have a rootstock that's very good at taking up nitrogen, like, you are going to get more vigorous shoots,
Right.
which would again impact your abscission.
Yeah, that it all
layer.
plays together.
So 7 points.
5-ish.
I
5-ish points.
I can't count past 5. I'm sorry. Oh man. But yeah, so even though the tree is trying to drop the leaves, there could be something that has interfered with the normal process.
Okay.
So apples are in fact not marcescent.
Right. That they are supposed to drop their leaves.
They are supposed to and are genetically inclined to drop their leaves.
Okay.
But there could be interference. There could be management potentially interfering with that, environmental, or it could just be in the genetics where you have ambrosia that isn't very prone
Right.
to dropping.
Right.
Or because it's a late cultivar, it's holding on to its resources as long as possible.
Right.
And because we have usually a colder winter,
Mhm.
then it could be the sudden switch
Okay.
that it's not allowing the time needed to actually drop the leaves.
Yeah.
But they still have that layer
Right.
intact.
Right. Which is why a lot of times, like this time of year, there's much less, like a couple blocks that we know of, right, that were really holding on to their leaves.
Yes.
Have now in the last like month or so, have dropped significantly.
Yeah, and that's because of wind
Yeah.
or
Yeah,
whatever
yeah.
else is actually
That they're so that they
taking them
were
out.
they were ready to drop the leaves, but they just hadn't finalized it.
Yes.
And so then, yeah. Okay.
So yeah, that's all I have. But basically, apples don't marcesce.
Don't marcesce. So there you go. Okay. Myth busted.
Myth busted. But very cool term.
Yeah.
And,
And that it does
learned a lot.
apply to other things. But that's interesting. I like though that like does it meet these qualifications, right?
Yes.
That like is it yearly? Is it, what did you say? Yearly
Species.
species that across all the entire species.
Yep, across the entire species. Is it consistent across individuals and years?
Right.
And is the abscission zone anatomically incomplete?
Incomplete. Okay.
So
I like
very
it.
cool.
That's cool.
Yeah, I learned a lot
Yeah.
looking into this.
Yeah. Thanks for
So-
asking that question.
Yeah. I guess I came up with this question.
Well, no, I like again, it's one of those things of like that's a usual thing, especially with ambrosia, everybody, and the concerns of like, is this going to cause problems, right?
Right.
And you're right, like some years it's really obvious, other years it's not, and so that always on those years, and this I think ambrosia was holding leaves this year for a lot of people.
Yeah, we got
And so
winter
that's-
very quick.
Yes. Yeah.
So that doesn't surprise me.
Yeah.
But again, like, no question is a dumb question,
No.
because I've learned a lot. I continue to learn, and I think that that's the beauty of growing a perennial crop or being in the perennial crop business industry.
Yeah.
Is that we're constantly learning, and we're very fortunate where apples is a crop that is being researched globally.
Yeah.
So why not ask the question?
Completely. And with with more and more cultivars and rootstocks, that, there's not going to be all of the answers right away. Like it's going to take years of growing something and the combination of growing something to really start to see how it responds in what environment with the changing seasons, all of those sort of things, right? There's so much that comes up with it.
Yep.
It's fun.
Yep.
I like it. Okay, cool. Nicely done.
Thanks. Can't wait to hear about your topic.
I know. Mine is really exciting. It's something that people love to talk about. And that is government regulations.
Oh my gosh.
Are you on the edge of your seat? It's a little bit of a pivot from our classic pest topics, still very applicable. And I do want to say that I kind of take the approach of this area similar to my recommendations for pest management.
Mm-hmm.
And that's if you want to see changes, you have to understand what you're dealing with first. So to me, I think the more questions about regulations, policy, all of that stuff, I think the better, because it's about having open communication, having everybody at the table understanding and on the same page so that we can make progress and make things so that all teams are happy.
Yep.
So yes, and it's tongue in cheek that it's everybody's favorite topic, because I know it's a huge headache.
Mm-hmm.
And I know that at times it can seem really illogical, the processes that kind of come through. And in particular, trying to understand labels are some of the worst times.
I don't know about you, but I love dissecting a label.
Oh, God.
It brings joy to my day.
The difference between them, the nuances to them, it's just so frustrating. And one of the biggest things that's part of that are the re-entry intervals.
Very, very critical. Fun.
And speaking of seeming illogical, sometimes they just don't make sense. So I think every grower knows that, they can think of labels or they can think of products that they work with that, you get a restricted entry interval of 12 hours, you get a pre-harvest interval of 7 days, or switching, you get a re-entry interval of like 3 days and a pre-harvest interval of 1 day. So you can pick the fruit, but you can't go in to pick the fruit, right? So again, face value, it really doesn't make sense.
Right.
So I want to kind of unpack the science behind it and sort of explain as to why those values are selected or how they come to those values.
Mm-hmm.
And then kind of, again, reinforce that there are things that growers can do if they feel like it's not representative of real life. So, but we'll get into that kind of as we go.
Sounds good.
So I think first and foremost, just kind of definitions of REIs, PHIs. So REI, restricted entry interval. So that is basically the minimum amount of time from when a pest control product has been applied to a block. We're going to talk about orchards. So to an orchard block, the minimum amount of time to when an application went on to when a person can enter in without any sort of required personal protective equipment or PPE.
Right.
There are rules around you being able to go in before that time, but again, the required PPE has to be in place. So this is just kind of to continue on with your regular activities, minimum amount of time. So the primary focus of a restricted entry, or I'm going to refer to it as REIs a lot throughout this because we love abbreviations.
Yes.
The primary focus is on worker exposure, and that's through direct contact with the treated surface. So whether that is through like dermal contact, so actually, touching,
Yep.
or inhaling any sort of sprays or anything that's kind of in the air.
Yep.
So that's the focus for REIs. PHI, or pre-harvest interval, that's the minimum amount of time from when it's applied to when it can be harvested. And the primary focus of this is on consumer exposure.
Yes.
So when a person eats an apple. So we can already kind of see the setup here that they are looking at, those two intervals are looking at two distinct exposure routes.
Right.
And protecting two very different populations.
Yep.
Right. So we're going to take a step back and talk just for a second in terms of the registration process. And so in Canada, some people may know this, some people listening may not. So in Canada, all pest control products, so that's anything that, if you look at a label, it has a PCP number, that stands for pest control product. That's kind of your classic pesticides, insecticides, fungicides, herbicides, nematicides, rodenticides, you name it. Let's name them all.
PGRs.
Yes, and that's what I was going to say. So there's the classic, what you think of as pesticides, but then other things that have PCPs are things like plant growth regulators, all of those sort of things. So the idea of what classifies a pest control product is anything that's detrimental to the crop or has a negative effect on the crop. Not saying negative in that it impacts, it's going to affect how it grows or anything like in a bad way.
Physiological change.
It changes it it takes away. So it could inhibit, it could kill, it could alter, that sort of thing. Whereas if you think of something like a fertilizer,
right,
it's contributing or it's a positive effect on a tree, what you're adding in, right? So pest control products are anything that has a negative effect. So all pest control products are registered, regulated by a subset of Health Canada, known as the Pest Management Regulatory Agency. We love acronyms, so PMRA is what we refer to it as. So they oversee all things related to, how products are applied, the legalities around it. So when a registrant, so a lot of times it's like a chemical company, when they have a product, they would submit this really extensive data set or data package to PMRA for review. And there's a number of things that are a part of this package. And that all kind of comes into play in terms of the assessments that happen. So a really big part of their data package is toxicology. So that's anything from, acute effects, short-term, long-term chronic effects. It looks at, the different routes of exposure. So again, that kind of the dermal versus ingestion, all of those sort of things. It looks at carcinogenicity tests. So that's like cancer and tumor development. It looks at fertility and reproduction effects, all of those sort of things. So all toxicology studies that exist for that product are included. So that's going to help kind of shape the human health risk and kind of the acceptable daily exposure or intake. So toxicology is the first thing that's submitted. The residue chemistry of the product is important. So how does the product break down? How does it behave on a surface? Kind of, you think of like the half-life. Are there byproducts that exist as the product breaks down that could be of risk? Does it settle on the surface, or does it dissipate, or does it give off some gaseous effects?
Mm-hmm.
So all of that, sort of just the overall idea of what is the chemical, how does it act, what are the residues remaining. So that helps to set the maximum residue limit, so MRLs, and that applies to all products. That's the highest legal limit for residues on a crop. And that's at any time. And so that limit is so high above the limit that would cause any sort of human health risk, like just to kind of put everybody
As
at
a
ease.
safety, yes.
It's a thing called safety factor, or safety margins,
Right.
that any sort of regulatory body is going to take into consideration. So it's not that, at this limit, anything above that, you're going to start to see human health risk. It has a major safety factor that's associated with it.
Yeah.
So MRLs are the highest residue limit. And that takes that information is taken from that chemistry package.
Right.
It also influences the pre-harvest interval, and that residue level is way below the maximum, the MRLs, right, as well. So in that kind of data package, they draw that information to set those intervals.
Mm-hmm.
So the third part of the data package is then occupational exposure. So that's how workers or anyone in the field are then exposed to the chemistry. So it takes into consideration the activities that happen in the crop, the duration that you do them, the frequency that you do them, and how much you interact with the crop while you're doing it. So, I mean, if you think about things like hand thinning, in terms of how long during the day, right? So, they would take into consideration hand thinning would be done at this time of year. It would last over this period of time, this many weeks or whatever that you'd be doing it. They would be working, 6 to 8 hours working through this. They would be coming in contact with the tree in this sort of way based on kind of the movement through the orchard, as opposed to, are you just walking through the row middle and not having any sort of kind of interaction with the tree. So the activities are really varied in terms of your contact.
Like even for scouting, right?
Scouting, yeah. Yeah. Are you going in and checking a trap, or are you going in and looking at terminals? So you're turning the leaves over and touching the foliage and all that sort of stuff. Are you checking your irrigation lines and, like those sort of things? Like there's different activities that happen and different engagement with the tree. So they take that into consideration. So those three, then as well, we've got the environmental fate and kind of the ecotoxicity. So where does the chemistry end up in the environment?
Yes.
How quick is the half-life? Does it kind of just break down and disappear, or does it have a tendency to, maybe hold on to something in the soil? Where does it end up in the waters? Yep. And then what sort of impact does it have on sort of the non-target species in the environment?
Yep.
So all four of those areas are all included in these assessments. And what PMRA does is they take those data packages and all of the information that's been provided to them, and they feed that into their risk assessment models. And from there, they decide, what is the human health and environmental risk. And again, before they even do any of their full assessments, they're applying those safety factors, which are, 100-fold or more,
right,
to really buffer. And that takes into consideration the fact that populations are so variable. Mm-hmm. And so you kind of consider the individuals of a population that are at highest risk. So something like children, pregnant women, that sort of thing. So applying that safety factor takes into consideration the variation. And so we always have this large kind of margin of safety with our values, or take a lot of kind of conservative assumptions, right?
Which is good.
Which is good. And I have to say that Canada, I mean, as frustrating as it is
Mm-hmm.
from a registration standpoint and product access standpoint, Canada has one of the most rigorous scientific evaluations for their regulatory system.
Mm-hmm.
And so I feel myself, kind of knowing the science and the process behind it, I feel very confident in the safety of the products and our crops. So I think there's a lot to say when it comes to that they do really do their diligence in terms of understanding both human health and environment.
I would wholeheartedly agree.
Yeah.
Never am I really thinking about whether this is safe or
Yes,
not when I'm
completely.
consuming something that was grown in Canada. We
Completely.
have a very strong food safety.
100%.
Yep.
So if I kind of mentioned, where we kind of pull some of the intervals and information from in terms of that data package. So you would be setting your PHI,
Mhm.
or not you would be, PMRI is setting the PHI based on those residue assessments.
Yes.
Right. And so looking at kind of the breakdown of that and, where, again, that's based on consumption.
Right.
Setting the REI, that would be
Physical.
majority would be the occupational
Yes.
exposure assessments.
Yep.
And so again, taking into consideration the types of activities,
Yep.
the frequency, the duration, the intensity of all of that sort of stuff. So all of the use pattern information is what gets fed into that. And it tends to be more short-term toxicity. The outcomes of that, right? That they the significant impacts are the acute toxicity that can happen with direct contact.
Yes.
So we've kind of alluded to the differences between them, why it is that we see them, again, because at face value, a lot of times it can seem really illogical.
Mm-hmm.
But once you start to consider, again, how those assessments happen for each of those intervals, then you can start to kind of understand why it is that there's differences. So I wanted to kind of go through, a few specifics of why we would be seeing a difference between REIs and PHIs.
Yep.
So I already talked about different exposure pathways.
Yes.
So again, PHI is ingestion by the consumers after harvest, whereas the REIs are based on direct contact of the workers after the application has happened, right? So different pathways and different populations that they're looking at.
Right.
So there might be a situation where you have a product that degrades really quickly, and so that it's deemed safe for consumption. So it would have a short PHI, yet at the same time, it still poses a threat through direct contact in the orchard after it's been applied. So that's why you can get, that variation that there might be a longer REI period, but the product breaks down fast enough that it can be harvested and consumed in an efficient time.
Can I ask a question?
Absolutely, you can.
Does the assessment take into consideration the environment of timing of when it's applied? So like weather, like sunshine hours or something, because potentially the product could degrade faster,
right?
Depending if it's, a fall application versus a midsummer application.
Right. Yeah, because there are some products that are like UV sensitive or anything like that. So that would entirely depend on the data that the company has and that's submitted.
Oh,
right?
interesting.
So
okay.
hopefully those are things that they look at, because that's a significant part to kind of how to apply a product, is understanding, does it break down quickly?
Yeah.
How, what's the residue for wash off, all of that sort of thing. For a lot of new products, they may not have that information right away.
Yeah.
And so that's also too, and that'll be kind of a point later on of like reevaluation. So products, once they're registered, then they go through a cyclical reevaluation period. So it's not just that they're registered and Hero World have at it for the next 50 years.
Yeah.
So it's part of the cyclical reevaluation process that they always revisit products every, I'm not going to say the years because
however often, because things change.
Things change depending on capacity and everything like that, right?
Yes.
And so so that gets reviewed, and there's new data that they look at. So there's new things that kind of come to play that then change how the models are used, or what sort of use recommendations, all of those sort of things come into play. So yes, so sometimes that's considered if that information is available.
Okay.
Yeah.
Very cool.
Yeah. So different exposures is kind of the primary difference between REIs, PHIs,
Yes.
but it's also important to consider the fact that they have different safety factors. So when you think of REIs and the fact that it looks at worker exposure, it's taking it to, it's kind of, the model is working from the assumption that, that this is, frequent contact that the worker is having, right? And so frequent and, repeated high risk contact. Again, you think about hand thinning, that they are in contact with the treated surface for X number of hours a day. And, if you're hand thinning, depending on the canopy structure, then how much are you reaching into the tree and getting, having that kind of potential exposure, right? So they work from that assumption that it's a repetitive exposure. Whereas something like PHIs, because it's ingestion, it's based on consumer ingestion, that's considering that it's a low level, kind of intermittent in their diet. You're having 1 apple a day, right? You're not
Minimum.
having,
Sorry.
Depends on the person. Based on the doctor recommendations, that they say 1 apple a day. So you're ingesting 1 apple a day, as opposed to, you're picking 2 bins per day, right? So it's different in terms of how they consider your exposure. So because of the more frequent, repetitive exposure, then they put higher safety factors on that, right?
Understandable.
Yeah. Another difference that could be is the difference in terms of the crop and activity. So this is more, especially for those mixed crop growers that are sitting there going, why can't I go in this crop for 7 days, but I can go in this crop in 4 hours?
Right.
And so it's going to, the REIs are set entirely on the activity that's happening in the field, right? What is actually going on. So some crops are mechanically harvested,
Mm-hmm.
some are hand harvested. You think of the crop architecture, some has a really dense canopy that you have to have contact with, whereas others, it's open canopy, there's not as much exposure, right? So that all varies depending on the crop and depends on the activity. So you're going to have that kind of variation. Whereas PHIs, because those are based on ingestion and not on worker behavior, then there's not as much variation between that value.
Okay.
Right. The other thing goes into what we were talking about in terms of the data availability. And so the package is really whatever that registrant has available.
Right.
So they might have a really robust package of, the chemistry, right? That they really understand well how the chemistry breaks down, how it interacts with the environment, all of those sort of things, the residue levels.
Mm-hmm.
So you could set a really good PHI, a really solid PHI, whereas they don't necessarily have the data on worker exposure for a specific activity.
Right.
And so because of that, wherever there is data that's missing or that's lacking, what the PMRA does as part of their models is that then they provide or they use their default.
Standardized, yes. Yeah.
Right? And typically the defaults are very conservative.
Yep.
Makes sense. It's also based on the information that they have at hand. And so if they don't have the most up-to-date recent information in terms of activities or how things are done in a crop, then those values can be skewed, right?
Mm-hmm.
So you just kind of have to be prepared that if the data is just not available, then they have to take conservative assumptions that are going to affect what happens, right?
Yep.
And the last thing in terms of like feeding into that, kind of plays into that, is then how the models have changed over the years. We talked about that there's reevaluation, cyclical reevaluations.
Yes.
So what was in place, what we've seen in apples too recently with like the group M's,
Yes.
that we had more freedom for application and for intervals. And then all of a sudden, these new labels came out that really restricted the use.
Yep.
And that's based on new information that's available. So new data feeding into the package, more refined models that they do for assessments. All of those things change over time. And, as much as a headache as it is to growers, and it's a big change to have to adjust with this stuff, those models are new and improved, right? Because it is taking into, you would want to, as I'm assuming most growers are concerned about human health and are concerned about environment. Like this is their livelihood, and this is where their families and workers live and thrive.
Yeah.
And so if there is a product that, based on new information that's become available, indicates that it does pose a risk to worker exposure, or it does pose a risk to the environment, then that's important information to have and to change. I understand that when that change happens, what we want is to have alternatives to come in and replace that. And that is often lagging behind.
Right.
And so when there's a use pattern change, then a lot of times it can seem what's my options? And that's understandable and a complete frustration.
Yep.
It's not that that's downplaying that. But it is that there is new scientific data that supports the change.
And as I said during my spiel, working in a perennial crop, you're consistently learning.
Yes.
Science has changed a lot.
Yep.
And we're always getting more and more data.
Completely.
And think about the changes that happen in a production style from an orchard, 40 years ago compared to now.
Yeah.
Products are going to change.
Completely.
The way that you're growing has changed. So shouldn't the way or the models that are being used from a safety standpoint also change?
Yes, completely.
Yep.
Yeah, well said. Yeah, so that's kind of, some things that could explain why there's those differences.
Yes.
The overarching thing is that there's it's different exposures, it's different assessments, and so the reasons for them are valid. It's why there would be differences, right? Because they're not measuring or not protecting the same thing,
right?
So the point that I really want to drive home, though, is that, and we talked. This is a good theme today. That that the science is only as good as the data, right?
Yeah, it's crazy how much relies on that.
Yeah.
But, rightfully so, though.
Right? Yeah, completely. And so I think that's where growers play a critical role, because they are the ones that can share the real life use patterns that can then be fed into these models to make it more realistic.
Right.
Because as we said, if they don't have the information, if the regulatory bodies don't have the information, then they have to use conservative values.
Yeah.
Whereas if we are in a place where we're sharing that information and providing the input, then they can feed that into their models to make things a little bit more realistic.
Yeah.
And so that's going to help with very activity specific REIs. Right. So for PMRA to understand, for PMRA and registrants, because they submit the packages, to understand more information about the activities done. So in terms of, how do your workers hand thin? How do they go through the orchard and prune? What are the typical practices? What's your tree structure like? How much water volume do you use when you spray? All of that sort of information is going to feed into and help support this. And PPE too is another important thing, because they have to take, again, for that safety factor, they have to consider the worst case scenario. So even if you're doing all of these things, they have to think, but there might be a person that doesn't, right? So they always have to factor in worst case scenario. But their worst case scenario has to also be informed. So if you are using PPE for hand thinning, or if you are doing all of these certain activities, then having that information provided to them is going to help them then adjust. Okay, this is more of a real world scenario,
Mhm.
right? So yeah, that's really, again, it's going to help refine those REIs. It's going to help with understanding the occupational exposure models, all of that sort of stuff. It's also going to really help to support the continued use of the products that you already have. So when it comes to reevaluations and all of that sort of stuff, then that information is what's going to be used. So I can't stress enough for grower participation in terms of information sharing. You know, it can sometimes be a little contentious of, you know, government versus grower. But I think that there needs to be a flow of information between the two. And so that would be things like sharing your information with your grower organization,
Mhm.
right? It could be participating in pesticide use surveys if those are available.
Yeah.
A really great way to share information, and one that's, you know, it has a significant impact, is the open public consultation periods for products. So any product that's going to be registered or any product that is under reevaluation always has open public consultation, and anyone can provide comment. It can be an individual grower, it can be an organization, it can be a larger, you know, representation of multiple organizations. The more voices at the table, the better.
Mm.
And so all of those sort of opportunities to share the use patterns and how their operation works is really going to go a long way to making a more realistic label in the future. So REIs, REIs, PHIs might seem a lot of times like they're just arbitrary numbers, but they aren't.
Yeah.
There is a lot of science that goes behind coming to those conclusions, and we have to be aware that it is ever evolving and dynamic because of science.
Yep.
And so what used to be may not be in the future, or what is set is based on the proper assessments that have taken place.
Mhm.
And again, it's about sharing that information to make it as realistic as possible.
Well, I will say you made REIs and PHIs very interesting.
Did I?
From my
yes.
And well, I know that it's probably not great for me to say, but I didn't really understand the difference.
Right.
And that's mostly because I usually handle PGRs, but
Right.
that's pretty much it.
Yeah.
But still, I should know that.
I mean, they
And I
still
should-
go through the process,
and I
right? There's
should-
still a PCP, right?
Yeah, I should be aware of it.
Yeah.
So, I mean, as always, I learn. I learn whenever we have these episodes. So I always appreciate it because I'm one of those people that I'm not going to be searching up pest related
right.
information because
Right.
I'm like, Christy's got it. I'm covered.
We're
She's
good.
great. I don't need to.
But then again, I still think like what I said at the beginning, that like, to me, it's that if you want change, and I mean, I'm like this with everything.
Yes.
If you want to see change, you need to understand it, right? You have to understand why the other party is doing what they're doing.
Yes.
And that then using that understanding, then you're able to, you know, make the changes that you want to see happen.
Yeah, it gives you a bit better reasoning.
Yes. Yeah.
And it's always good to understand different perspectives.
Yeah.
So.
Doesn't make it any less frustrating when you
No.
see those intervals and it's
Yeah.
like, this doesn't make any sense. But again, there's science behind it.
There's always a reason. Right? Yeah.
So there we go. We did it. My hands are
I'm
frozen.
so sorry. Should have asked you to bring mitts.
I should have brought mitts. I'm a big girl. I should have remembered that it's winter time.
I wouldn't say that you're a big girl, Christy.
I'm an old girl. Is that what you're saying?
No.
I have experience. I should have drawn from
You're
that.
wise beyond your years. Are we not allowed to comment on physical? Oh no, that's our alarm.
That's our alarm. Okay, we got to go then. we got things to do.
We got things to do. Okay.
Well, but that's perfect timing though,
Yes.
because this is great. I'm glad that we're back. I missed you.
I missed you.
This is nice being back here.
It is, even though I'm freezing. Well, thank you again for joining us between two rows where
Answers grow on trees.
Until next time.
Bye. Cheers, everyone.